Good morning. In this session, we evaluate a secondary cell referred to as the mercury cathode cell. The mercury cathode cell is a unique cell which has unique properties. Namely, it's composed of an anode made up of lead 4 oxide paste. It's made up of a cathode made up of a lead rod and made up of an electrolyte composed of concentrated sulfuric 6 acid. The role of these agents is mainly to enable the transmission of charge. The main reaction, however, begins at the cathode, where we have the lead rod. In this case, the lead rod dissolves in the electrolyte, and when it does so, it precipitates lead ions, and these lead ions are the main precipitating agents that are propelled to the cathode. Now, these lead ions, which we have said are in the cathode, are subsequently interacted with sulfate ions in the solution, in this case the electrolyte, to precipitate lead sulfate. Now, since the lead sulfate is insoluble and not readily reversible, we find that the cell reactions will come to a state of a halt because of the precipitation of lead sulfate. In this respect, therefore, the cell will be rendered non-rechargeable. However, it is a rechargeable cell simply because when you add water to the cell, the net result is that the reaction process is reversed and the previous raw materials are regenerated, namely lead 4 oxide at the anode, lead rod at the cathode, and the electrolyte sulfuric acid. The only difference would be that the sulfuric acid, which happened to have been concentrated, when recharged, will no longer be concentrated but dilute. That means, therefore, that after a recharge, the cell may not operate at 100% or optimum states. In this respect, therefore, let us see what happens at the cathode. The cathode, as stated, is made up of a lead paste made up of lead 4 oxide, and this paste is mainly the reagent that gives us lead 4 ions. The lead 4 ions have to be reduced, in this case, to the effectable lead 2 by the gain of 2 electrons in the solution to form the lead 2 ions. Once the lead 2 ions have been formed, they are subsequently interacted with the sulfate ions in the electrolyte, namely the conc sulfuric acid, and they precipitate the lead 4 oxide. In that case, when they form the lead sulfate, the cell reactions are rendered depleted. To recharge the cell, we have said that we simply take the precipitate, in this case lead sulfate, and dissolve it readily in water. And when it dissolves in water, we have described that it will reprecipitate the lead solid. It will also give us the lead 4 oxide and will subsequently yield sulfuric acid, in this case as a dilute agent. This reaction is a unique process which we are referring to as the recharge process. Now, the lead acid accumulator is a common cell that is used in motor vehicles. The unique property of motor vehicle batteries is that it has a compartment made up of a series of 6 to 12 lead acid cells. The lead acid cells, when multiplied, will yield a high quantity of charge, in this respect effectable for the driving of a motor vehicle and even tankers. Thank you very much. That has been a description of the mercury cathode cell. In my next clip, I'm going to describe and represent briefly the chemical processes in this particular cell. Thank you.